Today we're getting into section 2.4, which is algebra proofs. So one of the things that I've been mentioning to y'all over the last few days is that the reason we were going through the sentence stuff was to talk about the forms of logic that you need in order to really have the true evidence that you need in order to prove something. Now, a proof in mathematics, specifically in geometry, is essentially us going through a problem and justifying all of our steps. Before we get into the geometry proofs that use more of those geometry things that we've learned, we're going to get the structure down by talking about algebra first. Because in our geometry proofs, there is a lot of algebra things that go on. Within algebra proofs, there are a number of different properties that we can use. First of those properties is the addition property of equality that states that if I have something where it says something is equal to something, I'm allowed to add something to both sides. Now, here's the thing. Y'all know this fact. I know you know this fact because I know that if I gave you a problem that said x minus 5 equals 8, the first thing you would tell me to do in order to solve it is to add 5 to both sides. That's the addition property of equality that you're using. Now, when you're going through and doing proofs, you have to justify every single step. And that's, I know, going to be the thing that for some of you are going to be like, I hate proofs because it requires me to write it all down. And yes, it does. You have to show all your work. You have to write the justification. Now, in the justifications, the technical justification for doing the adding to 5 to both sides is technically addition property of equality. And that's what, in a technical, most specific proof, what you would have to write down. If you have to write down all of those words every single time, it becomes a bit much after a while. So, generally speaking, I just tell you to write add. So we're going to use the symbol statement a little bit, loosely, the symbol word. Okay, subtraction property of equality. If you have something equal, you can subtract from both sides. Again, this is something you would have already known. The quote-unquote symbol, the shortened version of subtraction property of equality I'm going to have you use you can write the full word subtract. That's perfectly fine. You at least need to write all the way up to the R. Multiplication property of equality. If you have something, you can multiply on both sides. In our justification, we'll shorten that down to mult. Division property of equality. If you have something, you can divide the same thing on both sides. Div. So those are your basic solving things, but there's also some other things that we commonly do in solving. One of them is substitution. Substitution states that if A is equal to B, then A can be substituted for B, so it can be replaced in there in any equation or expression. You can replace something with what it's equal to. Now here's the thing. Y'all know this one too. We've been doing substitution. We've been doing substitution throughout our problems, like when we come across a problem that was segment addition postulate, where we added up this and added up this to make the full thing. You solved for x, and then the problem said find AB. And you had this information that you knew AB was equal to 2x plus 7, and you now had found that x was equal to 5, and so you plugged it in. That is substitution. Substitution is SUBS in its shortened form when we put it in our proofs. Distributive property of equality, that idea that you can multiply through parentheses. Generally, we know this word, so I'm just going to say can distribute. DIST is generally what I do for a shortened version. And the last thing that's on here is, remember, you can also simplify equations by doing things like combining like terms. SIMP is simplify. So, as you're going to go through today, we're going to be just doing some algebra problems where you are justifying what you're doing. Technically, it's an algebra proof. It's that lead-in to our geometry proofs, which is going to be our main focus. When you are doing this type of proof, a couple things that I want to emphasize. First off, when you're doing proofs, they work downwards. On top of that, things are stacked. So those of you who typically do your math moving off to the side, you can't do that for this. You got to work downwards in these solves. You must show all your work on the steps. And by show all work, I'm going to get a little bit more into what that specifically means for these problems. But you have to show all the steps is the most specific thing. And you have to justify them. But especially with the fact that you work downwards, some of you I have noticed the entire trimester, even though I've probably said it a couple times already, that when you initially get a book assignment, the first thing you do is write number 1, number 2, number 3, number 4, number 5, number 6, whatever it is along the side for your problems. You're going to need to stop doing that immediately because you do not know how much room these problems are going to take, and you have to work downwards. So, on the top of your homework assignments, write down the page number as well as the problem numbers, and then don't write the problems along the side until you're done with the previous one. If you had to skip over a problem, give yourself a bunch of space, skip over it, and then move on to the next one. Okay, solve and justify each step. We're going to start off with the equation 3x minus 4 is equal to 53, and this one actually solved it for you. Now, in these problems, when you were initially given an equation, the justification is it's what you are given. So you just write the word given. It does not need to be capital or lowercase, or I don't care about that. It's a word. It's not a specific notation. Now, as you go through these things, this problem is considered a two-step solving problem. Hence, there's 2 lines. When I said you need to show your work, what I mean is I need to see essentially these 3 lines. What you started with, as given, what you got after the first step, and what you got after the second step. The actual thing where we write out what math we did is not actually required in a proof. It might help you. It's not wrong to put it in a proof. But these are what the steps look like. If I went from here to here, what did I have to do? Add 4 to both sides. You don't have to write the plus 4 on both sides. You just have to do the addition to get 3x equals 57. And since you did addition, guess what we write here? add. It's what you did to get there. To get from here to here, what did we have to do? You divided by 3. Again, you don't have to write this. You have to write the x equals 19 and that you divided or div. Okay. That one gives you the structure. This one talks about what we did. Okay. Negative 9x plus 3 equals 219 is what we are given. I want to solve that. Next thing I'm going to do is what? Minus the 3. Again, I don't have to write that piece. The part I do have to write is negative 9x equals 216. And I also have to write that what we did was subtract. S-U-B-T-R. Negative 9x equals 216. To get x alone, divide by negative 9. Again, you don't have to write this little piece. You do have to write x equals negative 24. And the step we did was divide, D-I-V. So far, nothing too scary. It's math that y'all have done plenty of times before. The only difference is now we're having to make sure we justify those steps. I'll take that. Okay, 2 plus x over 7 is equal to 6. Trying to get x alone. What's the first thing I should do on this one? Because I know these ones trip people up a little bit. Subtract the 2. When you are trying to solve, you're doing PEMDAS backwards. Add, subtract first. What's being added and subtracted with the x is the 2, and it's positive. So we subtract the 2 from both sides. I'm left with x over 7, and it's equal to 4. To get rid of a divide, we multiply. X equals 28. Now, did you notice I missed a key thing that I'm supposed to be doing? The stuff on the sides. Now, you can do the stuff on the side afterwards. There's nothing wrong with that. The only thing I will warn you about is sometimes when it gets to the longer problems, you might have forgotten how you got there. So I do recommend you do it as you go. How did we start? Well, we were given. Then the next thing we did was subtract. And then we multiplied. No, I do that just because it's me. Most people don't do the period at the end of subtract and the multiply and the divide and the add. Okay? This one looks similar but also different. To solve it, we approach it differently. Do I do the adding and subtracting first here? No. Fraction bars create invisible grouping, so we got to get rid of the 12 before we can touch anything on top, because those are grouped together. Okay, so I got to get rid of divide by 12, and to undo divide, we multiply. Oh wait, I started with the given. now I am multiplying, and I'm multiplying by 12. Do I multiply the 12 by the x, the 9? On this side, what actually happens?
It would just go to the 12 and the 12 would just go away.
Yeah, the two 12s just go away because you're multiplying by 12 and dividing by 12 simultaneously. I'm left with x minus 9 equal to 3 times 12, 36. Get x alone, I need to get rid of the 9. It's being subtracted, so I'm going to add. X equals, not negative, positive 45, and the way I got there was by adding. Okay, thank you. 2p minus 9 equals 10p minus 17. We want to get the p's together. Now, I am purposely going to move it to the right side because I want to talk about something with this. So I'm going to leave the 10p on this side. I'm going to move the 2p towards it, because that's going to be an important thing that we need to talk about. Now the 2p is positive, so I'm going to subtract it. Ooh, I started with my given. Now I'm subtracting. Negative 9 is left is equal to 8p minus 17. Add what? Add 17. Good. I heard add, so I knew that. Negative 9 plus 17 happens to be 8. 8 equals 8p. To get p alone, I'm now going to divide by 8. On this side, I'm left with a 1. On this side, I'm left with p. Now, did you notice that I did not specifically flip those two around right away? Have you noticed I've done that most of the trimester where I haven't flipped them immediately? Many of you I know have been like, why don't you just do it immediately? It's because of what happens when we come across proofs. In a proof, you technically cannot flip-flop what side things are on without doing a step in the proof. So, I do want to flip-flop these. I do like p equal to 1. Now this is a, what? When you get to the proofs, you're going to end up having to do it. Honestly, today you don't have to. But when you get to the proofs that we're going to do, there's going to be a reason why you have to. So I wanted to talk about it and give you a little introduction to it today. Not that you started doing it today and then had to unlearn it. And the property that allows it, it's known as the symmetric property. We're going to talk about it more tomorrow. And it's shortened SYMM. Now I'm second guessing myself if there's two M's in symmetric.
You're right.
Okay, thank you. Spelling is not my favorite thing. I am a math teacher for a reason. Okay. So we got two more problems. 34 parentheses 3x minus 10 equals 122 is what I am given. Oh, I heard it. What am I doing first? Distribute, which is one of a possible steps we can write. I distribute 34 times 3. I'm guessing it's 100 and something. 102? Just 102 or 102 something? X. Minus 34 times 10. I could do that one easily. 340 equals 122. By the way, if it helps you organize to draw a line between the left side and the right side, you can. We will start doing that on the proofs. When I say the left side and the right side, I mean the actual math and the words. Add the 340. 102x is equal to 462. We got there by adding.
It's 462.
I don't know what you're talking about. That was clearly a 2 the entire time.
Accidentally.
How do we finish it? Divide. 502. Does it mean we did something wrong? No. Decimals can happen. Now, when it comes to this, there's a couple of different things that you might need to be aware of. On these ones, if you write a decimal, I would round to 2 decimal places. Make sure you're rounding appropriately. We'll chat about that here in a second. Or you can write it as a fraction, which I know fractions aren't y'all's favorite things, but do you know that the calculator knows how to change things into fractions? If you struggle with simplifying fractions on your own, all of the calculators have the ability to simplify a fraction. You just have to find the little F and D pointing arrows on these ones. Now, initially it's going to give you a mixed number. I don't like mixed numbers. Mixed numbers are terrible. Don't do it. But there's also a mixed number change into a fraction button. So you can do that as well. And yes, it is 77 over 17. Do you have to do that? No. You can write it as a decimal. When we get into the proofs tomorrow, there might be times where fractions are necessary. You're never going to get to anything this ugly. Now, I did say if you're going to round to 2 decimal places. Let's chat about rounding real quick. If I want 2 decimal places, do I just chop it off and call it 4.52? When you're rounding, you always have to look one number further and say, is that number 5 or bigger? Is that 5 or bigger? Yeah. Yep. If so, the number before it increases by 1. If not, the number before it stays the same. Does this sound familiar? So, be careful of your rounding rules. In this case, the 9 was bigger, so the 2 does increase by 1, and it becomes a 3. 4.53. How did we get there? We divided. If you wrote 77 over 17, that's perfectly fine too. If you're going to do a fraction, make sure it's simplified. Okay. Final problem that's on here. It's the first thing you tell me to do in solving. Right, given, and subtract. Subtracting what? The 2x. Or you could subtract the 3x if you want to skip using the symmetric piece. But, so 2x is more commonly what we would do. 6 equals x plus 33. Next thing we would do is subtract again. X is left on the right side. 6 minus 33, negative 27. And if I do want to flip it around, because that is my personal preference, and there will be a time where you might need to do that, The shortened version is SYMN for the symmetric property. So, a lot of today is algebra that you've been using. It's just got that justify piece. So, today we're in section 2.4, part 1. Today is the 27th. Our homework's due on Tuesday, which is October 1st. I didn't know that. Okay, we are on page 92. Day 1, again, when I see write day 1 or day 2 on the assignment, when you write your page number, please write that as well. It is numbers 3 through 12. Did y'all notice there's technically something else happening today, though?